Hello. Thank you so much for the invitation here. I believe, if I'm correct, that I am the token pathologist speaking. So I'm sorry, and also, hi, thank you for inviting me. We are going to be very focused on the diagnostic aspect of glomerular diseases in dogs and cats, and in particular, immune complex-mediated glomerulonephritis, or ICGN. So let's get going. As disclosure, as Dr. Quimby mentioned, I am the current director of the IVRPS, which is the International Veterinary Renal Pathology Service, which is currently located at Texas A&M. We will briefly go over some background of glomerular diseases in dogs and cats with particular focus on ICGN, the pathogenesis of ICGN, and then really getting into how do we diagnose this in a clinical setting, i.e. using the comprehensive renal biopsy and some of the work that we have done with validating minimally invasive biomarkers in particularly in dogs, but we're working in cats as well. So let's dive right in. That's a kidney, you know that. If we do a quick breakout of this kidney, we know that the functional unit are the nephrons, and we have many, many nephrons that are composed of the glomerulus and the tubules, very basic. Here's our glomerulus. Let's zoom in a little bit. We already heard a bit about the anatomy of the glomerulus with the afferent and the efferent arterioles that are feeding and draining the glomerulus, the capillary loops, which I'll zoom in a moment on. We have the Bowman's capsule surrounding the glomerulus that is lined by parietal epithelial cells that encapsulate the urinary space. And within the center of that glomerular tuft, we have the mesangial cells. And mesangial cells are very interestingly and very interesting but not fully understood cell that not only support the development or the production of the glomerular basement membrane, but also have a significant role in immunity and inflammation modulation within the glomerulus. And so I think over time we're going to learn more about their function, but these are a somewhat fascinating cell. Let's zoom in on that capillary loop. We have the podocytes, which are a fascinating and beautiful cell that surround these capillary loops. They, interestingly, the Podocyte Society in human medicine, their mascot is the octopus because, body, legs, yes, that is a podocyte. And we have all of these podocyte foot processes that surround our basement membrane, the glomerular basement membrane, which the collagen and components of the basement membrane are predominantly or very heavily produced by the mesangial cells as well as other cells. And then we have our fenestrated endothelium that surrounds our blood space and allows for regulated filtration of proteins, as we heard a little bit about protein regulation a little bit there in the previous talk. So our glomerular filtration barrier is, as I said, composed of that fenestrated endothelium, the basement membrane, and the podocyte foot processes. Any damage to any of those components or other cells or components within the glomerulus will lead to glomerular damage and proteinuria and all of the clinical signs and abnormalities that we see thereafter. So just in general, causes of glomerular damage would be glomerulonephritis, which we will be focused on today, amyloidosis, diseases of the podocyte or injury to the podocytes, such as focal segmental glomerulosclerosis, so sclerosing diseases, and diseases of the glomerular basement membrane. So let's hone in now on glomerulonephritis. In human medicine, categories of glomerulonephritis and glomerular diseases in general are classified much more and much better than we currently have in veterinary medicine. I think we will get there eventually, but as with so much in veterinary medicine, we are behind compared to human medicine. The glomerulonephritides in people are divided into those that are driven by immune complexes here, those that are driven by complement dysregulation here, the C3 glomerulopathies, and then those that are not driven by either immune complexes or complement dysregulation. And in veterinary medicine, while we occasionally, and actually I should really say infrequently, see the C3 glomerulopathies, predominantly what we see for the glomerulonephritides are the immune complex-mediated glomerulonephritis. Right to date, we don't see these other diseases. And then ICGN is then subcategorized even further in human medicine, and some of those are even further subclassified based on the inciting cause. Okay, so when we look at animals, particularly dogs and cats, and a major study that was done in dogs, looking at the hierarchical, wow, I can't say that, cluster analysis of histologic evaluation of renal biopsies in dogs with proteinuric diseases. Those proteinuric diseases divide into two major categories, which are the ICGN, or the immune complex-mediated glomerulonephritis, and non-ICGN. So, that's a pretty broad split there, right? We then can classify those further based on histology and additional advanced diagnostics. Again, we're going to be focusing here on the ICGN diseases. And the predominant forms of immune complex-mediated glomerulonephritis that we see in dogs and cats are these two, which are the membranous glomerulonephritis and the membranoproliferative glomerulonephritis. Okay, so we've already heard a little bit of this, and again, I am a pathologist. I am not a clinician, so I diagnose, I do not treat, and nor do I pretend to be able to give treatment advice. So I will simply say that the clinical findings that we see in our patients with glomerular diseases, oftentimes proteinuria, and this can frequently be moderate to pretty marked. And then the remainder of these are sort of a plus-minus situation. They may happen, they may not. So hypoalbuminemia, azotemia, decreased antithrombin activity, and potential dysregulation of our coagulation cascades, hypertension, elevated cholesterol, and then buildup of fluids. In many cases, our patients may retain their ability to concentrate urine. Very importantly, none of these findings or the values, analytes, that we look at in clinical pathology can distinguish individual glomerular diseases. So I cannot look at a urine protein creatinine ratio and say, that dog definitely has ICGN, or that dog definitely has amyloidosis. I might lean a little bit more towards one or the other type, ICGN versus non-ICGN, but I really can't definitively say that without a renal biopsy. And so that's where I get into our service. The International Veterinary Renal Pathology Service was started at Texas A&M, moved briefly to Ohio State University, and it is now back at Texas A&M University. We currently offer evaluation of comprehensive renal biopsies as well as urine SDS-PAGE, which stands for sodium dodecyl sulfate polyacrylamide gel electrophoresis, so that's why we call it SDS-PAGE, for global profiling of proteins in the urine. And we'll talk about both of these further. We also explore and validate novel biomarkers of kidney disease in companion animals. So when we look at glomerular diseases in dogs, through the IVRPS, what we see is we look at those major breakdowns we see about a 50-50 split of our cases in our database of ICGN versus non-ICGN. So again, it's really hard for us to say, well, most of the biopsies that we get are from ICGN. We cannot say that. We have a very pretty equal split of these diseases in our patient population. And our service receives biopsies from around the world, so I can't say that this is the split that we see only from the United States. Granted, most of our cases are from the United States and North America, but we do see cases from around the world. Similar studies looking at prevalence of glomerular diseases or dogs that were biopsied for suspicion of glomerular diseases have been performed in North America as well as mainland Europe plus UK and UK by itself without mainland Europe. And in the North American study and that by Dr. Aresu in Europe and the UK, we found, again, a very similar split, about half ICGN, half non-ICGN diseases. Interestingly, we, when the UK alone was evaluated, it was a smaller study, it had a smaller proportion of, or a smaller prevalence of ICGN in those dogs. And it was suggested that this may be due to a variation in the antigenic causes or the underlying causes of the immune complex development depending on the region that a patient or that an animal lives. And so we don't have a lot of data for countries outside of, or continents outside of North America, Europe, and Australia. So for those of you that are potentially elsewhere, feel free to submit samples to us, and we do take international samples. We, very importantly, these studies, again, emphasize what I previously said, that our clinical and laboratory data are not very useful in distinguishing the specific categories of disease. I'm going to skip past that for sake of time. In glomerular diseases in cats, as mentioned previously, we don't tend to get a lot of biopsies from cats. And when we do for proteinuric diseases, many of them, or a decent number of them, are immune complex-mediated glomerulonephritis, or at least a higher proportion than we see in dogs. And in a study, actually, Dr. Quimby was the mentor on this particular study. They found similar findings as to what I currently have right now in our database, that about 58% of cats had immune complex-mediated glomerulonephritides. And again, clinical and lab data cannot distinguish those categories. Just very briefly, our breakdown in cats for the ICGN disorders were predominantly leaned towards membranoproliferative and membranous glomerulonephritis, which I'll talk about more in a second. So why does this classification matter? Why do we care about being able to divide these up into ICGN, non-ICGN, and then the subcategories therein? Well, this really comes down to correct treatment and prognosis. So antiproteinuric therapies, including a proper renal diet, are commonly used for both ICGN and non-ICGN. But when we have immune complex-mediated glomerulonephritides, immunosuppressives are often added, and frequently with our patients, and not I, but others that treat patients, are having to modify those immunosuppressives dependent on the patient response. And so accurate diagnosis is really needed to avoid an unnecessary risk of immunosuppressive therapy. And without comprehensive renal biopsy, it's been demonstrated that we actually have frequent misdiagnosis of the glomerular disease, such that using either biomarkers by itself, or I should say traditional biomarkers by themselves, or only a partial renal biopsy that maybe only looks at light microscopy may overdiagnose or underdiagnose ICGN, and therefore instigating the wrong therapy. All right, I've already said that. So let's get into some pathogenesis real quick. Formation of immune complexes. Immune complexes are simply an antigen plus an antibody, and they may or may not have complement component added in there, okay? So Rarely in our veterinary species do we actually identify what the inciting antigen is. Oftentimes, when we are suspicious of ICGN or potentially have a diagnosis of ICGN, we then have to go down a diagnostic route looking for a potential infectious organism or cancer or something that contributed an antigen and is driving the disease, because it's ideal to clear that antigen if possible. Most of our patients, we end up suspecting that there may be an infectious component that incited the disease, but again, we oftentimes do not know specifically which antigen was present. Immune complexes come in a couple of flavors. We have circulating immune complexes as well as in situ formation of immune complexes. Circulating immune complexes are when we have antigen and antibody that are in relative equivalence and are circulating, or slight excess of antigen compared to antibody. And these are circulating in the blood. They become embedded in the glomerular basement membrane. And then we have the next step, which we'll talk about in just a second, which is activation of complement. They can also form in situ. So we have some antigens that are very good at penetrating the glomerular basement membrane, at which point then antibodies come along and they bind with those antigens, and we have an immune complex developed in the glomerular basement membrane. What happens after those immune complexes are there? They can be cleared potentially, so especially if our inciting antigen is taken care of or cleared. So if we have a patient that has a disease process and that is resolved, sometimes we potentially have clearance of those immune complexes. Or they can potentially enlarge, and so they can combine with other immune complexes or other antigens, antibodies, complement, et cetera, and get larger. And this is especially common with chronic antigenemia. So these patients that we're not clearing very quickly, or maybe we have not recognized an underlying disease. So where I'm from is Texas. Texas has a lot of bugs, and we get a lot of heartworm disease. And so that's a common chronic infectious agent that can cause chronic antigenemia and result in glomerulonephritis. So going back to our general pathology of what happens in the complement cascade, so these immune complexes set off the classical pathway of the complement cascade, and just for simplicity's sake, we have formation of anaphylatoxins C3A and C5A. These anaphylatoxins recruit inflammatory cells as well as cause degranulation of mast cells and basophils, and we have formation of the membrane attack complex. So when those mast cells and basophils are degranulated, we have release of products like histamine that, that cause increased vascular permeability. And so we have widening of those endothelial spaces. And this allows for even further deposition of immune complexes. So that's not ideal, right? Neutrophil chemotaxis and degranulation from the anaphylatoxins, so these neutrophils are drawn into this area. Their goal is to phagocytose the immune complexes, but in this process, when they degranulate, we have release of lysosomal enzymes as well as other products, free radicals, that cause damage to the glomerular basement membrane as well as other cells and components throughout the glomerulus. As I mentioned, we have the formation of the membrane attack complex when that complement cascade is initiated, and that complex causes disruption or direct injury to other cells throughout the glomerulus, as well as the kidney itself, including tubules. So podocytes are damaged, endothelial cells are damaged, mesangial cells are damaged, and as I mentioned, damage to any component of the glomerulus can lead to problems downstream like protein leakage and proteinuria, as well as cell detachment, particularly podocytes really don't like to be damaged, and they will detach or become significantly damaged and unable to provide their appropriate function of filtration. As we have these damaged cells present, they release chemokines that can then further recruit leukocytes and perpetuate inflammation and damage within the kidney and within the glomerulus. We also have activation of the coagulation cascade due to presence of this significant inflammation, formation of fibrin thrombi, and potentially leading to glomerular ischemia. Okay, cool. I'm checking my time. All right. So comprehensive renal biopsy is one of the main things that we do we evaluate at the IVRPS, and diagnosis of these glomerular diseases really definitive diagnosis really relies on this comprehensive renal biopsy. As I mentioned, light microscopy alone is insufficient for an accurate glomerular diagnosis, glomerular disease diagnosis, and so we frequently need immunofluorescence and transmission electron microscopy to provide the most accurate diagnosis possible. For sake of time, I'm not going to talk about obtaining the biopsy, but for those that are interested, I encourage you to explore into literature about obtaining biopsy and some of the complications or requirements to get a good diagnostic sample. Okay, so now we're going to get into the world of anatomic pathology, and I will try not to bore you too much with this, but with light microscopy, there are 4 major stains that we require for any suspicion of glomerular disease, and these are going to include hematoxylin and eosin, which allows us to assess inflammation within the glomerulus and cell morphology, but by itself is insufficient. Importantly, these biopsies for light microscopy need to be sectioned at a very small, very thin micrometer, so at about 3 micrometers. This is smaller than you would typically have other histologic sections like liver section, which are usually about 5 micrometers. The reason for this is that we need that single cell layer in order to be able to detect changes in the glomerular basement membranes as well as hypercellularity, which will determine which direction we're going with a disease process. And if they're too thick, we have potentially overdiagnosis of certain glomerular diseases. Periodic acid Schiff is one that we commonly use, or PAS, that helps us distinguish the basement membrane, distinguish between podocytes, endothelial cells, and other cells so that we know which cells are actually hypercellular or hypertrophied. And they let us look at the tubular brush border. Masson's trichrome, which is the Spider-Man stain because it should always be red and blue. And we section that again at 3 micrometers. It helps us look at the glomerular basement membrane and the extracellular matrix. So specifically, we have a lot of scarring. We'll have a lot of blue. And it helps us detect immune complex deposits, which I will show you later what that looks like. And then the Jones stain, or the Jones methanamine silver stain, is really helpful for looking at the glomerular basement membrane. Another common stain that we use, not for ICGN, but if we're suspecting amyloidosis, we use Congo red. That's sectioned a bit thicker. Okay, so as I mentioned, we oftentimes need immunofluorescence for an accurate diagnosis of ICGN in dogs and cats. And these are to detect the presence of immunoglobulins and complement components that have formed due to the presence of immune complexes within the basement membrane. Now, we use an arsenal of antibodies in dogs and cats, which are specific for dogs or cats, whichever one we're looking at. This right here is lambda light chain that is staining 2 glomeruli. These are the same case, and so we have the same 2 glomeruli here. Both of these are negative, so this is C3 and lambda light chain. Neither of these have any lighting up of their glomerular capillary loops, so we have all these capillary loops throughout here. Versus this guy, this is IgG in a dog that was definitively positive for ICGN. And the classic feature of immunofluorescence for ICGN is this granular pattern of staining, or lumpy bumpy. So we have these capillary loops, and we see little dit dots all along those capillary loops. And the presence of that granularity, that lumpy, bumpy appearance, is more important than the intensity or the brightness of the, so sometimes we'll get some of these that they have a granular stain, but they're not nearly this bright where it's not burning your retinas. But sometimes we do where they're so bright that I have to actually turn down the fluorescence a bit on the microscope because, whew. Additionally, we have electron microscopy, which is again, often required to provide that definitive diagnosis of ICGN. And this really helps us with looking at glomerular basement remodeling and presence, again, of immune complexes. And this is a gorgeous set of capillary loops here that is normal in a normal dog. And we can zoom in a bit here. We have our blood space, or our capillary space. This is a red blood cell. All along this inner layer, we have the fenestrated capillary endothelium. We have the basement membrane along here, and then we have the mother podocyte with podocyte foot processes in perpendicular orientation to the glomerular basement membrane. So as I mentioned, glomerular diseases in dogs and cats are divided into ICGN and non-ICGN, and most commonly we see MGN and MPGN as our most common ICGN forms. I'm going to talk a little bit about those, their differences diagnostically. So membranous, or MGN, the light microscopy findings that we see, so those with those 4 major stains that I talked about, are not specific for MGN, meaning that other diseases can mimic this on light microscopy, and this is part of why IF and TEM are so important for a definitive diagnosis of immune complex-mediated diseases. When we have membranous glomerulonephritis, the immune complexes are deposited on the abluminal side, i.e. away from the lumen of the glomerular capillary. They are located subepithelial, i.e. underneath those visceral podocytes. I'm sorry, the visceral epithelial cells, which are the podocytes. And they typically do not cause a lot of inflammation. While they do trigger the complement cascade, we typically don't have a lot of neutrophilic inflammation that occurs due to them being farther away from the immune system, i.e. they're not right up against that lumen. So when we have an early membranous glomerulonephritis, we oftentimes don't see a lot of changes on light microscopy, and therefore we do need immunofluorescence and TEM available, but we have capillary thickening when we actually start to see changes on light microscopy without hypercellularity, and we'll have a thickened glomerular basement membrane. This is a fascinating, I love these pictures from Joan's stain, where we actually see production of spikes and holes around the immune complexes that have been deposited. So when I have one that is a pure membranous glomerulonephritis, we will see these little spikes that are developing around those immune complexes that are embedded in the basement membrane, and sometimes these little holes. Hopefully you can see sort of those little notches there. And this is all remodeling around those immune complexes. With the Masson's trichrome stain, we can also see deposition of the immune complexes in these little dot patterns along the capillary loop. So it's these little red dots here. So we're oftentimes looking for these as well. Now, that's well and good when we see these on light microscopy, but in many membranous glomerulonephritis, we don't have these changes. This is usually a bit more chronic. And so when they're early, we don't see these changes. And therefore, we need IF and we need TEM. And as I mentioned, we have that granular pattern of staining along the capillary loops that are due to deposition of the immune complexes, and they're lighting up with either our antibody or complement stain. For electron microscopy, we will see immune complex deposition in that subepithelial location. And so here is our mother podocyte right here, and she has all of her little podocyte foot process out here, which are damaged at this point. On the inner side, we have our fenestrated capillary endothelium, and we have the basement membrane in here, and all of these dark spots here are our immune complexes that have been embedded in that glomerular basement membrane. Here's just a zoomed in picture where you can see that beautiful fenestrated endothelium and those complexes that are right beneath the podocyte foot processes. So membranoproliferative glomerulonephritis is a little different than the membranous form, where we have immune complexes that are on the luminal or the subendothelial side of the glomerular basement membrane. So they're sitting right below the fenestrated capillary endothelium. And we also potentially have immune complexes within those mesangial cells that were in the center of the glomerular tuft. The glomerular tuft, sorry. Compared to membranous, this is a highly inflammatory form of ICGN. Their proximity, the immune complex proximity to the vasculature, drives inflammation very heavily. And so what we tend to see in these cases, we have endocapillary and potentially mesangial cell hypercellularity, as well as, so we'll have podocyte hypertrophy, endothelial cell hypertrophy, mesangial cell hypertrophy, as well as influx of inflammatory cells, so we can sometimes see neutrophils in there. The Jones methanamine silver stain will demonstrate something called double contours, which are remodeling, again, around mesangial cells that undergo what's called interpositioning, where they slip in there into the basement membrane, as well as around immune complexes. And we develop periglomerular fibrosis, and we can see, again, here's some neutrophils that have invaded into those capillary spaces. So these are all some changes that we'll see on light microscopy, but similar to what I mentioned with membranous, none of these findings are definitive for ICGN. They're highly suggestive of it, but we cannot say for sure that it is immune complex driven at this point. And therefore we need our famous immunofluorescence to look for those granular immune complexes. Compared to MGN, now we not only have these immune complexes that are lining the capillary loops, but they're also frequently within the mesangial regions, the mesangial zones. And we will see immune complex deposits that are subendothelial. So now we have moved, here's the podocyte side, or our podocyte foot processes, our basement membrane, and then this side is the capillary loop endothelial side. So here are our immune complexes that are deposited on the luminal side or the subendothelial side of the glomerular capillary loop. Okay, so hopefully I've made you very excited about histology, which is what we look at all day long. But now let's talk about some promising biomarkers in dogs and cats. And I'm going to talk about two of them that we're looking at in the IVRPS for sake of time, but I'm happy to talk more later if you would like. So urine SDS page is one of the diagnostic tests that we do provide at the IVRPS, and this is essentially an electrophoretic separation of the proteins that are in the urine. We utilize SDS detergent, which basically makes everything the same charge, such that the migration of the proteins through the gel are determined based on their size. And so we can assess proteinuria in a patient as to its origin of predominantly glomerular, predominantly tubular, or mixed, both. So to just point out what we're seeing here, our gel, we have our molecular weight standard here on this side. Lane 2, this is a normal dog. This is urine from a normal dog. We have a very, very thin band that correlates, or that is albumin, and then we have a very thin band that is present at the location for TAM-Horsfall protein. So that would be consistent with a normal animal with no changes on glomerular biopsy, or sorry, renal biopsy. We start to see some patients that have glomerular disease and or glomerular damage, and we'll start to see increases in intermediate molecular weight proteins and high molecular weight proteins. So we have this buildup of all of these high molecular weight, large size proteins that are due to that significant damage to the glomerular filtration barrier. In diseases that are predominantly tubular, so when we have primary tubular damage, we typically get less proteinuria, and the proteinuria that's present is due to usually small or low molecular weight proteins, and so we tend to get this banding pattern that's down here in the intermediate to low molecular weight region. Many of our animals have a mixed component because we have both a combination of glomerular and tubular damage. And the severity, first of all, the presence of glomerular versus tubular, as well as the severity of damage on these gels correlates with the renal biopsy scoring. So if I'm seeing a marked pattern of high molecular weight proteins, so multiple high molecular weight proteins, and they're very dark or intense, that correlates well with severe glomerular damage on renal biopsy. Okay, so when we get to our ICGN, what we started to notice anecdotally is that when we would run these gels in dogs with biopsy-confirmed membranoproliferative glomerulonephritis, what we found is that, not so much sensitive, but if we had an increased number of bands, particularly if they're very prominent, above 200 kilodaltons, so especially if you've got at least 4 bands above 200 kilodaltons, that was very highly specific for the presence of MPGN, such that I oftentimes, if I'm seeing this and the owners cannot perform renal biopsy, I will oftentimes say you might want to try an immunosuppressive cautiously, because obviously we don't have that definitive biopsy diagnosis, but you might want to try an immunosuppressive therapy. Now, if we also take into account not just the number of bands, but also their intensity, or we look at their optical density on on the program that I use to assess these, the sensitivity improves, but it's still pretty lame at 47%. So not a sensitive test for MPGN, but when I see it, I'm very concerned about MPGN. And I can't talk really about this at the moment, but we are exploring what these proteins are present in these dogs with MPGN. And very fun, we're seeing this in cats as well. So we're not getting, or we think that we're seeing this in cats as well. We need more biopsies for confirmation. Okay, so very recently released study on microRNA 126. So microRNAs are small non-coding RNAs that regulate gene expression, and microRNA 126 has a role in inflammatory responses, production of pro-inflammatory cytokines, and immunity. And in looking at RNA sequencing or microRNA sequencing in a set of dogs with naturally occurring glomerular diseases, specifically ICGN, all of the flavors of ICGN, and 2 non-ICGN diseases, amyloidosis and FSGS, looking at a small subset of those and performing RNA sequencing, we found that there was a significantly higher expression of microRNA 126 in dogs that had ICGN, regardless of whether it was membranous or membranoproliferative glomerulonephritis. Confirming that further, looking at a larger set of the dogs' samples that come through the IVRPS, using qRT-PCR, we confirmed that, yes, the microRNA 126 expression is significantly higher in dogs with ICGN compared to amyloidosis or glomerulosclerosis, or certainly our controls. And this seemed to be independent, again, of whether it was MGN or MPGN. We are further analyzing this now. We have a grant to analyze this further in other glomerular diseases and other renal diseases, as well as non-renal diseases in a larger population of animals. But this microRNA 126 provided correct classification of 90% of the cases, with a sensitivity of 90% and specificity of 92% for ICGN. And this is very exciting. This is something that we hopefully will be able to bring as a diagnostic test soon. I encourage you to read this manuscript by Dr. Cherry. Okay. ICGN in dogs and cats, driven by immune complex deposition that's often secondary to an underlying disease, particularly infectious diseases, that set off our complement cascade and resulting inflammation. We really strongly recommend that comprehensive renal biopsy for definitive diagnosis, but we understand that that is not always feasible for every owner and every patient, and therefore we're continuously working to try to develop biomarkers to help detect or at least suspect ICGN such that the clinician can be a little bit more confident in use of immunosuppressive therapy. I thank you so much for your time. I think there's a little bit of time for questions maybe, but if not, please feel free to email me at either my personal TAMU email or at our IVRPS email, and I'm happy to talk about studies or diagnostics, whatever, and if you ask me treatment questions, I will refer you to an internist. Thank you so much, I appreciate it.